Okay, guys, in this example, we're going to take a look at another function of two variables and evaluating the values and finding the domain. So here I have 2 natural log of y minus 3x squared plus 6. Okay, so the first thing to do is just plug in some of these values. So 6, for example. So I would get 2 natural log. So instead of y, I'm plugging in 6. And also instead of x, I'm also plugging in 6. Now, you need to remember that natural log is only defined for positive numbers. It is not defined for 0, and it is also not defined for negative numbers. So here I can definitely see that no matter what, this is just going to be some kind of negative number. So this is a negative number, and logs of negative numbers is undefined. So that, if you can just put D and E, that would be good. Okay, so the next one is something like 0, 0. So that will be 2 natural log of, well, I'm plugging 0 for y and 0 for x, so that's just natural log of 6. I do not need to actually convert that to a decimal. So I can tell, for example, that 0, 0 belongs to the domain of this function. So the domain should contain 0, 0. If I were to compute something like 1, 0, so now I'm plugging in 0 for y, so be careful what's what, and I plug in 1 for x. Okay, so this gives me natural log of negative 3 plus 6. That's natural log of 3. Okay, so this looks like also something that is defined but cannot be really further simplified, so I just have to enter it that way. Okay, f of 0, negative 5. So 0 plugged in for y, that's going to give me 0 minus 3 times negative, oops, y is negative 5. See, I just made a mistake there. That is really not good. Okay, so this is going to be negative 5, and actually x, whoops, x is 0. So this is going to be negative 5 minus 3 times 0 squared plus 6. So you got to be very careful what's what here. Okay, so I get 2 natural log of negative 5 plus 6. Okay, so that's going to be natural log of 1. Now, that's something that you should never, ever, ever leave just like that, because your teachers will probably not like it. So you are supposed to know that natural log of 1 is 0. So please memorize that. And of course, you can just use a calculator. Like if you don't believe me that natural log of 1 is 0, you can always use your calculator. We should tell you that, but don't leave it like this. People are going to say, you're supposed to know that, how to simplify that. So 0, negative 5 seem to also be in the domain. Well, how about 0, negative 6? So now I am plugging in again. I'm plugging in negative 6 for y and 0 for x. Okay, so that actually gives me natural log of 0. Natural log of 0 is undefined. So unlike the square root of 0 is defined, that is 0. But natural log is not. So like if I were to try to find natural log of 0, that's undefined. So compare that with the square root of 0. So what is the main difference here? So when I see the natural log and I'm going to try to decide which of these I pick, I am going to pick the one that has a dashed boundary, because natural log at the boundary will be undefined. At the boundary, that's when it's 0. Okay, so it should not include the boundary itself. Okay, so to graph the domain, the first thing I do is I drop the natural log, and I'm just going to make whatever is under the log equal to 0. So let's make the 0, which means that y is equal to 3x squared minus 6. Now, you should recognize that this is a parabola. How do I draw this parabola? So first thing that you need to notice is that this parabola has a positive coefficient of x squared. So this is a parabola that looks upward. Second, if you wanted to find its vertex, the vertex formula is negative b divided by 2a. This is where the x coordinate of the vertex of a parabola is. But b is the coefficient of x. And this particular parabola does not have an x term. And so what that means is that the vertex x value is just going to be 0 because there is no b. And then the y value of the vertex is found by just plugging in the x coordinate of the vertex into the equation, which is going to give me -6. So this parabola goes through 0, -6, and you really just need to, so this is the vertex. And you just need one more point to graph it, okay? So for example, when x equals 1, when I plug in x equals 1, I would get -3. So this is just some point on that parabola. That's really all you need, vertex and a point. So vertex happens when x equals 0 if the x term is missing. So let's see if we can graph that. So first of all, why did I say it was a parabola? Well, hopefully you can see that because the x was squared. Because if the x wasn't squared, this would have been another line situation, but this is a parabola. So I am going to pick this one. Why am I picking the dash one again? Because this is natural log of 0 is undefined, so on the boundary it's not going to exist. So let me draw the parabola. So I just need 0, -6 as the vertex. So let me place that there. I need a point. I just said that 1, -3 is that point. Okay, so now I have the boundary, but now I have to decide, okay, do I shade the inside or the outside of the parabola? Well, look at all these points. 0, 0 has to be in the domain. 1, 0 should be in the domain. 0, -5 should be in the domain. The way I did it, I actually shaded the outside, right? Because 0, -5, well, that's right here, right? So I did not do this correctly because the domain must include the points where I was able to compute the function. So this is not good. So I'm going to just clear it and redraw it. So again, 0, -6 is the vertex. 1, -3 is where this thing is going to have a point. And I need to shade the inside. Okay, why is that again? Because all these points like 0, 0, you see where the 0, 0 is right here? 1, 0, that's right here. 0, -5, that's right here. All of these points must belong to the domain. So that's why I'm shading the inside and not the outside.